I have here Blake Richards, a computer scientist and neuroscientist who studied under the Godfather of AI, Geoffrey Hinton. We're going to talk about Hinton, where you agree and disagree, his influence on you. We're also going to talk about why scientists who build and program AI can't figure out what it's doing, the interpretability problem or explainability. We're going to talk about AI safety and alignment, conscious AI, the future of work, lots of other things. But first, you say we might be able to accomplish more with AI by not designing it to mirror human brains. Can you talk about that?
Right. To go from the computer science to the biology, it was very overwhelming at first. There's so much in the biology, and biology is so complicated. I learned, though, the more and the more I tried to incorporate biological facts into my models, is that generally speaking, they made things more difficult. It was usually the case that like you'd have a neural network that worked, that did stuff, and then you try to incorporate some extra biological realism into it, and all it did was make it work less well.
Do you think it might be confounding now, but there might be ultimately an important reason buried in the biology about why it makes it work less well?
Yeah, I think that there is a very important reason, and that reason is that if you think about all of the facts that exist in biology, some subset of them are probably there because they helped our ability to learn and behave and perform in the environment. But a probably larger set of them are there because they were necessary for minimizing energy usage. They were necessary for the way that proteins get phosphorylated. They were necessary for genetic reasons. They were just holdovers from our phylogenetic ancestry. If you're just sort of randomly adding biological details to your model, 9 times out of 10, they're going to be things that have nothing to do with the algorithmic capacity of the model, and instead everything to do with these other extraneous factors that don't matter for a neural network.
So they're like vestigial
or other things that matter for the biology, but not for a neural network, right? A neural network doesn't have to worry about what it's going to do with the byproducts of the Krebs cycle, for example, right? So like it doesn't have to have these additional mechanisms in place for dealing with that. The exercise ends up becoming, can you figure out which biological details actually matter algorithmically versus not? It's not the case that biology hasn't helped at all. I am not someone who makes that argument. There have been very specific instances where the biology has helped us. And indeed, neural networks themselves were brought about by people thinking about how to model the brain. But there's sometimes a tendency for people to think, well, if it's in the biology, then it's helpful. And that has, in my experience, definitely not been the case.
So the AI interpretability problem or explainability is this problem where even the scientists who built and program these things don't understand and can't predict AI decisions. Why is it so hard to figure out what these things are doing or to predict it?
So the reason is that these systems are engineered using techniques for optimization rather than engineered for specific purposes. If you build a car, every piece of the car has been designed to achieve a certain function. But in what we call neural networks, we give it an objective function or a loss function. So we say, here's what we want you to get good at. So in the case of generative pre-trained transformer models, so they just say, like, I'm going to give you a sequence of words. I want you to predict the next word. How you're going to do that, I'm not going to tell you. We're going to give you this objective function of predicting the next word. And we're going to allow gradient descent, which is the algorithm that we use for training these networks, to find the right setting of the network that successfully lets you do that task. And as a result, when you go and you look in the system, there aren't little bits that are doing things that you've designed them to do, because you didn't design any part of the system except the overall system. You just had said, this is overall what I want you to do. So it's got all these different little parts, each of which is doing something that you never designed it to do necessarily.
And it's hard to read those parts. Are there too many of the parts? Is it just volumes of code that you can't? What does that look like in terms of challenging?
Yeah, so it's exactly that. It's hard to interpret those parts. So if you think of there being all these little neurons that you're simulating, really they're just numbers. They're vectors that you're pushing around your computer, but whatever. The problem is that it's very rare that you could look at the way that that neuron activates and say, this neuron activates when the system's going to do X, or when the system sees this word, or when the system is planning a sentence on birds, or something like that. It never happens in a nice, concrete way like that. Instead, it's very complex, whatever it's doing. It'll activate in response to the word bird in this one context, but not in this other context. And then in this different context, it'll seem to be representing whether or not the system is going to say something snarky or whatever. And it'll be highly contextually dependent, highly unstructured. And even though we know the mathematical function that leads to that, so you can fully describe the mathematical function, there is no set of human language words that we can give to the unit to say this is what it does.
So it's not just a matter of too much data that we can't possibly like comb through it all and piece it together. It's that we can't anticipate what it's going to do.
That's right. Yeah, exactly.
And that is a problem because there's nothing you can throw at it then. You can't throw manpower at it.
No, there's not. It's not just a case of like, oh, if you threw enough manpower at it, you can figure out how these systems are going to behave.
When you give AI a goal, does it always just like hyper focus on executing it?
Yeah, necessarily. So this is the reason that it can be potentially dangerous. Some people take it too far. Nick Bostrom's paperclip factory argument is like a sort of fun, taking it to the absurd extreme. But it's not totally crazy. What we do see with these neural networks is that the only thing we're actively designing them with is this loss function or objective function that we give them. So as far as the math that we're using is concerned, it's just going to do what it can to minimize that loss function or maximize that objective function. And so if you don't have a well-specified objective function, it's entirely possible that it's going to come up with bizarre techniques for doing it, right? Things that might end up being not what you want.
Since you straddle computer science and neuroscience, what's at least like one key difference between human goals and machine goals?
Well, I'm not sure there's a big difference this way. I think humans suffer from all the same foibles here. We see this in people all the time. People will get hyper-focused on specific goals that they have to the exclusion of a lot of other things that they maybe should be considering. And they will act in potentially terrible ways if it furthers them achieving certain goals. Per your other question about interpretability, humans aren't interpretable. When we drop electrodes in humans' brains, we have no idea what's going on. It's a mess. It's really hard to interpret what the different neurons are doing. So I think we're very similar. I think we're these huge systems that have been optimized by a combination of life experience and evolution. We have certain objectives that we evolved to have, and we will often try to achieve those objectives at the detriment of other potentially important things.
So if our goals are the same, what about other functions? Like, do you agree that large language models, at least at this point, are text synthesis machines?
It's not unreasonable to call them text synthesis machines. I think that's perfectly appropriate. What's remarkable is that when you actually give the system this task of synthesizing text that is indistinguishable from what humans generate, it necessitates it actually developing some understanding of the world as human language reflects it. There's a wonderful example I really like from Blaise Aguirre-Iarcas, the head of Google Brain in Seattle. He spent a lot of time interacting with Lambda, their previous large language model. He said to it, I dropped my bowling ball on my violin. And the language model replied, oh, that's unfortunate. I guess it broke badly. And he says, which? The bowling ball or the violin? It says, well, the violin, because it's fragile. Now, that would seem to imply that the system has an understanding of the difference in fragility between a bowling ball and a violin. And I think the answer is it does, because to actually predict all of the sentences that it had seen throughout the course of its training data, when it encountered sentences that involved bowling balls or violins, sometimes those sentences, you could only predict the next word if you understood that a violin was breakable and a bowling ball was not. So it's a funny thing. They are text synthesis machines, text generation machines, but that task of text generation requires a remarkable level of understanding of the world.
And so are we, right? Sort of.
Yeah, exactly. I would say actually that there's a lot of evidence in neuroscience that we are not radically different in terms of how we operate. It's just that we're not only predicting text, we're predicting our full sensory motor experience. So we are predicting all the things we see, all the things we feel, all the things we hear. That's what our brain is constantly doing every second of the day. And this is why we have an understanding of the world, is courtesy of the fact that to predict what's coming up, you have to understand the structure of the world.
So the next generation are multimodal models are not just trained on text, they're trained on audio and video. Do you think that's going to change the game?
Oh yeah, we'll see massive advances in terms of their understanding of the world, is my guess, and a much more human-like understanding of the world than the large language models. This gets back to your question about, do they do like anything other than just try to achieve the goal as we very specifically set for them? And the answer is no, they just try to do that. So the large language models will only develop an understanding of whatever is required to successfully predict the next word. But there's surely many ineffable things in our existence that aren't captured by our linguistic communications that these models therefore don't understand, but which a model trained on video data very well might understand more of.
And is it true that people are working on trying to integrate the sort of brains of AI models trained on language and video data into hard and soft robotics? So putting AI multimodal intelligence into robot bodies?
So people are working on this, but it's actually a remarkable engineering challenge. One of the reasons that this stuff first took off with large language models is because it's so easy to work with linguistic data. There's such large data sets of it. Literally just the RAM and memory requirements of operating with text are so much less than those with operating with full video. And once you tie in robotics, then it becomes really hard to collect enough data of the right sort potentially. There are maybe ways around this using simulation and other stuff like that. It's a much greater challenge than training on text.
Something just occurred to me. The hard problem of consciousness is that you can see microscopically neurons firing in the brain when a person sees the color red, but the microscopic neural activity is a fundamentally different thing than the experience the person is having of actually seeing the color red. And that the experience is called qualia. It's the qualitativeness of what it feels like to see red. But science has never been able to objectively point to it and be like, there it is. That's this thing is red. This is the redness of qualia. So hallucinations. Sensory deprivation can cause hallucinations in humans. I just wonder if AI hallucinations might be more closely related to human hallucinations than we're considering. Like maybe there's some sort of AI language-based detached from the world qualia to AI hallucinations.
Well, yeah, I think it's an interesting question. This gets back though to the problem of it maybe not actually being ever clear what's going on in these models, and we have to accept that. For example, with the question of hallucinations, I think there's a tendency for some researchers to try to downplay what these models accomplish. I think that tendency comes from a mixture of exhaustion with some of the over-the-top hype, coupled with some less fair kind of just bias against any success. And I think that there is a desire, therefore, to downplay some of the accomplishments that these models have made, and in part to then also say things that, in my opinion, are not justifiable. So even though I agree these models are clearly text synthesis machines, I would also say they hold some understanding of the world and they are intelligent. I have no problem saying that. By any reasonable use of the words understanding and intelligence, it applies to these models. Now, not the same way we are. They don't understand the world the same way we do. They don't have the same type of intelligence we have, but I think they're clearly intelligent systems that understand the world. That being said, this whole question of we can go and we can analyze their behavior and see ways in which they behave oddly. And hallucinations, quote unquote, is one of the examples that is given. But I think the hallucinations example is really interesting. And you raised an interesting point there. Do humans not do that? I think they do. Even if we don't ascribe that to qualia, you can just see that human beings generate false things all the time. This is not an unusual thing in human beings. If anything, we have to train ourselves not to do that. I don't know if you have kids, but I spend my time with my kids. In part, you train your kids not to generate confabulations and instead to always stick to the truth. And that's a commitment that you have to train them on. So I don't think that where we differ from these models is in our tendency to engage in these hallucinations or confabulations or anything. My guess with respect to something like qualia, though, and this is what I was getting at, is that we can't say whether these systems have qualia. I think that's an impossible question to answer for them. All we can say is that they surely don't have qualia like us, because our qualia is necessarily tied to all the things that we experience with our bodies. The red that we see, I don't think can be separated from the way that our eyes work and the mixture of photoreceptors we have in our retina. So does ChatGPT see red? Does it experience red? No, I don't think so. There's no way it does. Not like we do anyway. If it experiences anything, I don't know. I think it's an unanswerable question. My tendency is to think it doesn't, because I think probably we can say that it has missing from it all of these raw phenomenological things that embed us within the world, that make our qualia what they are. But could a robot have these things? Sure, maybe. And the more the robots like us, the more that we would probably be inclined to say that it might have qualia like ours.
So I just want to clearly capture your thought on whether AI is now at some level or could become conscious.
This is an area where Jeff had a big influence on me, but also the philosopher Ludwig Wittgenstein. The hard truth that most people are not going to be able to fully accept is that the dividing line between that which is conscious and that which is unconscious is never going to be clear or scientifically articulable. It's akin to the dividing line between that which is alive and that which is not alive. We can't actually draw a scientific line concretely. We can't say whether a virus is alive or not, as an example. That's not to say that there isn't such a thing as life. Some things are alive and some things are not alive. Our ability to say this is conscious and this is not depends on there being a stark difference. Something that is like us, we can say is conscious. Something that is clearly not like us, we can say for sure it's not conscious. But something that exists in that interstitial zone, like a virus, is going to be really hard. And I think that's where AI is going to end up sitting.
So we're going to have to make all these moral and legal decisions about AI without ever knowing for sure.
That's exactly it. I think we're going to have to make moral and legal decisions that will not be able to be guided by like, yes, this system is conscious. No, this system is not conscious.
What's a question I haven't asked you yet that I should be asking you?
One of the most interesting questions is where a lot of the data is going to come from for doing alignment. So like the reinforcement learning through human feedback has been key to making ChatGPT not be an absolute toxic mess. Moving forward, where exactly all that data is going to come from is a real issue. My understanding is that OpenAI paid a bunch of Kenyan dudes to interact with it to do that. For proper alignment, it's not clear to me that just subcontracting out to the lowest bidder is the right way to do it. So really thinking hard about our data sources and regulating data sources as well is going to be part of the picture that needs to happen here.
I think you're referring to the Time magazine article. It was a bit of a harrowing read where a Kenyan workforce earning somewhere in the range of $2 an hour had to label dark web content to make AI less toxic. It's like it's too horrific to say out loud, and I can't imagine the impact on the people labeling this stuff. Let me think of how to phrase this. As we're building these intelligent things, whether or not they're conscious, whether or not they're alien intelligence, if they're being exposed to the dark web as they're being born, do you think that's going to shape them?
Oh, it will definitely shape them. So it's not that they should be, as it were, sheltered from bad data. Quite the contrary. We need to figure out ways of training them to understand, to recognize what is bad data, which we do already to some extent.
Okay, but aside from making sure it doesn't just regurgitate toxic text, do you think it's going to change how it's, I don't know if you can use the word thinking, but how it's...
Yeah, that's okay.
Okay, well, so how it's thinking about optimizing these problems when it's been exposed to all this and we don't have it aligned yet. Do you think that's going to pose any problems?
Yeah, I think that will pose problems potentially. And I think there's interesting questions then that we'll have to ask about, and this gets to the point of like how we select data and how we design curricula for it. Again, I think to children, right? Like, it's not the case that what we don't do with kids is show them everything and then post talk say, okay, this is not so good, this is good, this is not so good, this is good. Rather, like as they develop the understanding of the world, then you start to introduce like some of the darker stuff and help them to understand it. So there might be ways to better structure it than just train on everything and then post talk alter your value functions.
So you're making me think I've been thinking about this backwards, because when I've been talking to researchers, I've been thinking we sort of have to get an understanding of what's going on inside AI black boxes before we tackle alignment. But it looks like we might never solve the interpretability problem, especially if there's some semblance of consciousness in there. And frankly, we don't have interpretability with humans, and we align or try to align society with our goals and values without ever understanding what's going on inside us. Like, what's your take on the order of alignment and interpretability?
Yeah, it's a good question. Yeah, my take is definitely what you just articulated. I don't think that alignment should depend on interpretability. I think interpretability research is cool. I think it's fun in the same way that neuroscience is fun. We would like to understand how these systems work. And we do a little bit of interpretability work in my lab, and I see lots of potential in that area moving into the future. Do I think it's necessary for alignment? No, not at all. I don't get why anyone ties those things together, because as you say, we do alignment with other human beings all the time with zero interpretability. The key to alignment is just ensuring that we train the models on the things we care about. and that's where, per what Jeff has been saying, what Joshua has been saying, what others have been saying, we do need some real regulations in this sphere, because what we need is it to be that you can't train up and release a model if you have not done the due diligence of ensuring that you've considered really all of the objective functions that this system needs to be given to be deployed safely in the areas it's going to be deployed. So it can't be the Wild West anymore. There has to be, as there are with drugs, with food, whatever, very clear regulations that say, all right, before you can release this into the wild, you've got to prove that you've met this, that, and the other conditions, and that your objective functions have been well aligned to the possible failure modes. And even still, things will slip through and cause damage, just as they do with drugs. The FDA is not perfect in its approval process, but it does better than if there was no FDA and people were just pumping out drugs willy-nilly and giving them to the populace, right?
Do you think AI's fatal flaw is optimization?
I think the honest truth is that that is the fatal flaw of all human endeavor. So, I think of this with respect to capitalism versus socialism as well. To some extent, capitalism is the economic approach of using objective functions, right? Rather than having an economy where someone comes in and centrally plans everything and says, okay, these people are going to do this, these people are going to do this, these people are going to do this, we're all going to work towards the collective good. We instead just set up the objective function of make money, and then you let things emerge as they do. And the reason we do that, and the reason we don't engage in socialism, is because, as with AI, it turns out that approach of saying, okay, this piece does this, and this piece does this, and this piece does this, is not really manageable for anything but simple machines. If you're trying to structure a really complex system, that approach rapidly becomes untenable. So you need to take this optimization approach to do anything complex. But as we've seen with capitalism, when you just maximize that objective function, you're going to get all sorts of weird other things that emerge that you don't necessarily want, whether it's ecological damage or massive inequality, etc. I don't think anyone has ever discovered a way to avoid this necessary trade-off.
Well, isn't it just regulation? Isn't it?
Yes, I agree. So regulation is the only way we have right now within capitalism to avoid that trade-off, and that's the kind of thing we need in AI as well. So you need systems in place not only to regulate the release of AI, but even you can think of regulation within the AI itself that says, okay, this is your objective, but there are certain things that you're not allowed to do, certain places you're not allowed to go with this solution space.
Well, that sounds almost manageable. Although, have you heard the new buzzword Malik?
No, what's this?
Malik. It's not really a new word, but it's sort of newly buzzy. It's about how we want to attribute all the evils of us hurtling towards the cliff edge of catastrophic climate change and nuclear proliferation, and now AI, the AI arms race, to evil heads of corporations and governments, but really it's just misaligned incentives, this cascade of misaligned incentives, which is if you're beholden to shareholders and maximizing profits, and you're going to do things that put your very existence and the existence of your children and your species in existential crisis.
Yeah, no, this sounds like exactly, it's that, misaligned incentives. That's it. Yeah. And that's the danger with AI too.
So Geoffrey Hinton, cognitive psychologist, computer scientist, and Godfather of AI. He won the Turing Award for deep learning. This is the award considered the Nobel Prize of computing. How did studying under him influence you?
It had a massive impact on me. I mean, Jeff is the kind of person who has a big impact on people. I use the phrase unironically that I totally drank his Kool-Aid. I had found my degree in artificial intelligence really frustrating, actually. At that time, it was largely class after class of things that didn't work. I was feeling really unimpressed with artificial intelligence, and it felt like it wasn't going anywhere. But Jeff's class was the first time I felt really excited by the ideas I was learning. I fully got on board with the idea that neural networks were the way to go, not only for artificial intelligence, but also for understanding the brain.
So what year was this then?
So I took Jeff's neural networks course in 2003, and then I was RA in his lab in 2004 to 2005. So this was right before some of his ideas about deep belief nets started to make waves. In fact, I was working with the model that they released that helped to kind of usher in the modern deep learning era, the one on stacked restricted Boltzmann machines to create deep belief networks.
Can you define deep belief networks?
So a belief network is a network where you've got each node representing a stochastic variable that can be on or off. And it has a probability of being on that's sort of your belief as to whether or not this thing is true. So you can make a prediction by activating this unit with a different probability. And a deep belief network is a network where you've got multiple layers of these variables that can be on or off, stacked one on top of each other.
Given that Hinton was such a big influence on you, what did you think about him sort of breaking the cone of silence and coming out as a whistleblower about the existential threat of AI the day after quitting Google?
I fundamentally, I think Jeff's doing it for the right reasons. He's ultimately a very ethical guy. You know, I don't know if you know this, but like one of the reasons he came to the University of Toronto was that he was uncomfortable with all the DARPA funding that was pouring through the universities he was at in the States. He's a lifelong socialist, and he's a very ethical guy. So I think he's coming from a very honest place with this. I think he's also right that there are some real potential dangers from AI systems. I don't agree with everything he said in every interview. It's not that he's saying anything wrong, but I think he's maybe overemphasizing some things. Like for me, I'm much less worried about the dangers of a superintelligence than I am about the broader dangers of breakdown of our social cohesion and democracy that could come about as a result of these things. But Jeff's also talking about that. So to be clear, this is why I don't disagree with him, but some of the concerns that are being raised about super intelligent systems, they're not crazy, but I see them as still less concerning than these more concrete things that I am much more directly concerned about.
So you're an independent researcher. Have you run into the problems with AI experiments and impartiality because you have to trust big tech companies who are by definition conflicted and might distort unfavorable outputs?
The specific scenario you just described is less a problem for us because we build our own models. What is the case is that we're in a weird place in academia right now where a lot of the most interesting models are not accessible to us, and we don't have the compute firepower to make versions of them for ourselves as it stands. There was a petition that I signed called LAION, Laion, which called on governments to invest in something like a publicly funded large compute resource for independent researchers, sort of akin to the Large Hadron Collider, but for AI, where researchers could build larger models using these communal compute resources. I would love to see something like that exist, because as it stands, we necessarily work at a smaller scale than the industry guys do. And the industry scale is important for achieving the state of the art. You need scale to get there.
Did you see the Google memo that was either intentionally or accidentally leaked, saying that open source AI, not open AI, but open source, actual open source AI models are going to bury big tech like Google and OpenAI/Microsoft? Do you think open source is an opportunity for independent researchers?
Definitely. That's part of what that petition I mentioned called for, is the creation of not just communal resources, but then that the results of those communal resources would be open source. Because I think that's the way to prevent this from all being controlled by small groups within industry. The thing that's not quite true yet is that as it stands, no one yet has built open source models at scale. But I think they're probably right that that's going to happen. And I hope it does. And if it does, independent researchers will be back in the game.
What do you see as the role of academia in the AI era?
The whole idea was that the marks you get in undergrad are supposed to be some reflection of your skills, and that employers or whatever downstream could use that as a signal about how intelligent you were. These systems necessarily break that model. But maybe this model needed to be broken because it's never been that clear that that was the best signal anyway. It might just be liberating to not have to be trying to learn stuff that you don't actually want to learn, and which, in my opinion, if you don't want to learn it, you're going to forget it once you leave the class anyway.
I mean, speaking about training data, I've been curious about this because I've been fact checking sacred tomes in the humanities, and many aren't passing a basic fact check. And I know these models are training on this stuff, and this is considered the pinnacle of quality training data. So I really wonder if there's a future where academics and students can fact check texts across liberal arts.
The other question for academia, though, is then the role of academic institutions vis-a-vis AI research. And so this is where I think we will get back to AI research being done, also importantly within academic labs. I think the particular situation we find ourselves in now is a unique historical juncture where we are at a point where putting a lot of resources, just engineering resources into it, have helped a lot. And it'll take a while for academia to catch up to that. And in the meantime, we're going to see the end of the same level of basic research being done in industry moving forward, because things work now, so they can engineer things and make products. And there will be less incentive for them to just pour money into basic research. And it'll mean that there will still be very open doors for academia in basic research.
So predictions about what the future of work looks like? Are we going to be AI babysitters and teachers and parents? Is that what the workforce is going to look like?
Some people will be, definitely. I think 100%. There'll be AI psychologists, AI teachers, AI babysitters, all these things. I'm sure of that. That's part of the reason that I'm in the long run less concerned about employment. I think that'll be really disruptive for employment in the short run, but like 100 years from now, I don't think it'll be so bad that way.
Any recommendations about what people should do in the short term to upskill?
Yeah. Well, learn how to use these models and make yourself more productive with them so that you can take advantage of it rather than be left behind by it. Or go into the trades or social work or something like that, which are totally safe.
And for anyone interested in studying human and machine minds like you, what was your path?
So I did my undergraduate in computer science and in fact, in a program at the University of Toronto that was specifically called Cognitive Science and Artificial Intelligence. So it was mostly computer science with a little bit of psychology and philosophy, but like 80% computer science. And then I did my graduate work in neuroscience. I was able to make that switch because I got into Oxford's 4-year EPhil program, which is designed to take students from different disciplines. And the first year is just like a catch-up year where they teach you the basics of neuroscience, so that even if you're coming from computer science like I was, you learn what a neuroscience student would know, or at least they try to do that. And they do actually a pretty good job of it. So I did my graduate work in neuroscience. Then my postdoc was also largely neuroscience, but since starting my lab, it's been a mix of the two.
And lastly, I've been corresponding with a lovely OpenAI rep trying to get an opportunity to speak with them. So do you have any questions you'd like me to ask if I get a chance?
If you are keeping things under wraps as you're doing now, so you're no longer releasing the model parameters, you're not being super clear on how you trained it up, on exactly what objective functions you used, how you collected your RLHF data, all these other things. Fundamentally, like, why should anyone trust that you're doing this in a responsible way? Do you not think that more transparency is needed moving forward to have people trust that you're not going to release something that's really bad for our society?
So you reject the Eliezer Yudkowsky claim that this is a good move because it reduces not the existential threat, but that a bad actor could get a hold of it and do something nefarious with it.
Yeah, I don't agree with that. I think the concern about the bad actors getting a hold of it, like, it's not that bad actors couldn't get a hold of some of this stuff, but even if they feel like opening the model parameters is dangerous for that reason, and I think there's an argument to be made that way, I'm less concerned about that. But let's even just go with it for a second. Let's say, yeah, you don't want to release the model parameters. I don't see any reason not to be transparent about how you've trained it up, what the exact data set is and stuff like that, because bad actors are going to be able to, if they're really committed, figure out how to build this anyway. And as it stands, we can't trust that you've done due diligence on alignment even if you're not going to open it publicly, there needs to be, a la the FDA, a regulatory board that you do give full access to, that can go in and make sure that you're not doing anything that could lead to fundamental misalignment.
Thank you, Blake.